Hello everybody and welcome back. We're continuing our look at the 2008 Pascal paper, that's the grade 9 multiple choice contest, and we're on question number 8, which involves a fella named Alex. Alex has $2.65. He has only dimes, which are worth 10 cents each, and quarters, which are worth 25 cents each. Okay, I guess technically this is $0.25 and $0.1, but quarters are 25 cents. He has more dimes than quarters. Okay, so we're not being told how many he has. It might be a good idea to give a name to the number of dimes and the number of quarters. And so what this statement is telling me is that the number of dimes is greater than the number of quarters. We're being asked, what is the smallest number of coins Alex can have? Well, the number of coins that he can have is just the number of dimes plus the number of quarters, which would be D plus Q. So giving names to these unknown quantities is pretty nice. Alright, so they're asking for the smallest number of coins, and to me, that suggests that there isn't an exact answer. Not that there isn't an exact answer for the smallest number of coins. No, that's not what we're talking about. I'm saying there isn't an exact way to sort of express 265 as, well, it's got to be 7 dimes and 12 quarters or something like that. We don't have that sort of a situation. So there's going to be some variability, some possibilities. Okay? So, it could be, well, he has 7 dimes and 12 quarters, or maybe there's a way to do it with 20 quarters and 1 dime. And so 7 plus 12 is 19, 20 plus 1 is 21, so you're going to choose the 19 coins as sort of your smallest solution. That's what I'm getting at here. Okay, so the quantities we've got named are really good. Might even write that down. D equals number of dimes. Q is the number of quarters. We are being told number of dimes greater than number of quarters. Fantastic. And we want D plus Q to be as small as possible. Alright, so what I'm going to do is I'm just going to sort of dive in and make a little bit of a chart. Okay. So, what do we need? We need the number of dimes. I'm going to move the decimal place over just to make my life a little easier. So instead of adding up to 2.65, I'm just going to say move everything to cents. So 10 cents plus 25 cents per quarter. It needs to be 265. Okay. And then we want to know, well, what's D plus Q, and get that as small as possible. Now, let's stop and think about this for a second. If we want the number of coins to be as small as possible, I would guess that we want the number of quarters to be as large as possible, because quarters make up a sort of a larger leap towards the total of 265 than dimes do. Yeah, you can get pretty close with dimes, but it takes 2.5 dimes to do what 1 quarter does. So 1 quarter is saving the place of 1.5 coins. By having a quarter instead of 2.5 dimes, you have 1.5 less coins, and that is good. So if we start to piece together a lot the sort of reasoning like that, the logic behind the question like that, we can sort of shoot for a very particular goal. And I think there might be a faster way to do this question than what I'm about to do, and I'll try and remember to come back to that. But with a question like this, I might just say, well, okay, we want 265. That's not a multiple of 10, so let's get 1 quarter in there. Subtract off 25, we'll have 240, and so 24 dimes would work. Okay, 24 dimes, and this is a great time to have your calculator handy to just really be able to very quickly fire these off. So, I'll even get my calculator out here. Okay, so, you just double check. 240 plus 25 times 1 is 265. Okay, great. And how many coins do we have? We have 25 here. Now, we could sort of mess about and say, well, what if you had 2 quarters and so forth? But once we have one combination like this, ask yourself, well, how many quarters do I need to make something that can be expressed as dimes? Okay? If I have 1 quarter, I can't just write that in terms of dimes. But if I have 2 quarters, I can write that as 5 dimes. So in place of 5 dimes, so get rid of 5 dimes, I can add on 2 quarters instead. And you can double check. 19 times 10 is 190, plus 3 times 25 is 265. And there isn't one involving 2 quarters that'll work. Okay? But now we see, we've dropped 5 coins but gained 2 more, so we've lost 3 coins here, and we can keep going on like this, losing 5 coins and losing 5 dimes and gaining 2 quarters, and that'll still work, and we'll get 19 here. We can drop 5 more dimes to 9 and gain 2 more quarters, so that's 16, and you can keep going, but do be careful, because the next time you drop your dimes, you'll go down to 4, and your quarters will go up to 9. Now, this still does work. This is 40 plus 9 times 25, and it is 265. And it's less coins, but we've crossed the threshold, and there are actually less dimes than there are quarters. So we've got a bit of a problem. So we don't want to count this one. We're actually going to go with 16 as our answer. That is the smallest number of coins, where the number of dimes is still greater than the number of quarters and adds up to 265. And if we check, there's 16, so our answer is going to be B, but there's 13, just in case you went a little too far. Okay, the people who make these contests up, there are some of them who just sit around saying, well, gee, how could a student misinterpret this? How could they screw this up? And for the later questions, you can quite frequently find that if you make one little arithmetic mistake, or if you get one little condition, or you make one little error in logic, that following that through, you'll get an answer that is presented. It just isn't the right answer. So we are going to go with 16. That's B. Now, I did say that by realizing that we want the number of dimes and quarters to be kind of similar, you want as many quarters as possible. So you want so knowing that we have to have dimes greater than quarters, and we want as many quarters as possible, then we should have dimes be about equal to quarters. And if we actually go back and look at the chart, where dimes and quarters were closest actually was the answer. 9 dimes, 7 quarters. Okay, but is there a fast way to do this? Well, if dimes and quarters are almost the same amount, then it turns out 265 is almost equal to the number of dimes plus 25 times the number of dimes. That sort of a thing. And so that's 35 dimes. Now I know 265 is not a multiple of 35, but it's pretty close. Okay, and so 265 divided by 35 is about 7. And so that should about be the number of dimes. Or you could also say it's about the number of quarters. Okay? If quarters and dimes are basically the same thing, you could do this sort of a calculation. And so if you tried something like, well, the number of quarters is 7, what dimes should you have? You'll get 9 dimes. Or if you tried, well, the number of dimes is 7, that doesn't quite give me the right number of quarters. 265 minus 70 divided by 25 is about 7.8. So we're not quite there, but we're hovering around the right answer, and so you might try the number of quarters is 8, or you might try the number of dimes is 8, or something like that. But I'd say this is a faster way to narrow it down, and one of these actually does yield the best answer. So that's sort of a shortcut, I would say. It's not entirely reliable. The reasoning is sound. The number of dimes and quarters should be pretty close together, because you want to maximize the number of quarters, but that's limited in some way by the number of dimes you have. So you want to get dimes and quarters as close as possible. But as you can see, if you rearrange and get, well, my dimes I should have about 7 dimes, you're a little off. So it takes a little bit of experimentation at the end, but it's sort of I would say it would be faster if we were adding up to something like 2,650 cents as opposed to 265 cents. I think the chart is more exact and it goes a little faster for this question. You can imagine a longer question that has a really, really big chart, in which case shortcuts like this may be a little bit better. But anyway, that finishes off question number 18, and we'll be doing question number 19 in the next video, so I'll see you guys there if you'd like to join me. And yeah, so 16 was the answer here, and that's B, and I'll see you next time.